Hey, welcome. So, the new in vitro diagnostic regulation, the IVDR, has totally changed the game for IVD manufacturers. But here's the thing you really need to get. The work doesn't stop once your device is on the market. Actually, that's where the real work is just getting started. Today, we're going to pull back the curtain on one of the most important post-market requirements, the PMPF.
So you did it. All that hard work paid off. You got your CE mark, and your IVD is finally out in the world. That's awesome. But the big question the IVDR is asking you is, okay, now what? You see, getting to market isn't the finish line anymore. Nope. It's the starting gun for a whole lifetime of watching, learning, and monitoring your device's performance.
So here's our game plan for today. First, we'll break down what PMPF actually is. Then, we'll get into the nitty-gritty of building your plan. After that, we'll look at the data feedback loop, super important, and then tackle the wild new world of AI and machine learning. And we'll wrap it all up with a playbook on how to sidestep the most common mistakes.
All right, first things first, let's get to the fundamentals. What in the world is post-market performance follow-up, and what's the big idea behind it?
Okay, so the IVDR itself calls PMPF a continuous process. And I'm telling you, that one word, continuous, is everything. This is not a report you file away and then forget about. The regulation demands a living, breathing system that is constantly taking real-world data and feeding it back into your device's performance evaluation for its entire life.
Now, it's really easy to get this mixed up with its cousin from the medical device side of things, PMCF. But the difference is pretty simple, and it's crucial. PMCF, that's post-market clinical follow-up, is for medical devices under the MDR. What we're talking about today, PMPF, is post-market performance follow-up. It's for IVDs, and it's all about keeping that performance evaluation updated.
Okay, so we've got the theory down. Let's switch gears and get practical. How do you actually build a PMPF plan that's going to make your notified body happy?
This quote right here just nails the regulator's mindset. A fuzzy plan that just says, oh, we'll do a literature search, or we'll collect some feedback. That's not going to cut it. You need the details, the real actionable stuff. Which sites are you going to survey? How many patients are you including? What are the actual timelines? Your plan has to be a real blueprint, not just a wish list.
Think about your data collection strategy as having two sides. On one hand, you have reactive data. This is the stuff that comes to you, usually because something went wrong, right? Like serious incidents or corrective actions. But you can't just sit back and wait for bad news. You also need to be proactive. You got to go out and hunt for information. That means doing systematic literature reviews, digging into user complaints to find trends, and keeping an eye on databases for info about your device and others like it.
Now this flowchart is really cool because it shows you the whole ecosystem. See that big post-market surveillance procedure on the far left? Well, your PMPF plan is nestled right inside of that. And that plan is what drives all the data collection activities we just talked about. You can see them right there, acting as the inputs that feed the whole system.
And that brings us to the whole point of this exercise. I mean, collecting data is one thing, but if you don't do anything with it, what's the point? This is where the data feedback loop comes in. It's the engine that makes the whole PMPF process work.
Let's look at our flowchart one more time, but focus on that middle column. All those inputs, from incident reports to literature reviews, they all get analyzed. And what comes out of that analysis? Well, the results are used to update your most important technical documents. That's the loop. The data feeds back to shape your benefit risk analysis, your risk management files, and, most importantly, your performance evaluation report. It makes sure your core documents are never out of date.
Now, for the higher risk devices, we're talking Class C and Class D, this whole process comes together in a big, formal document, the Periodic Safety Update Report, or PSUR. This thing gets updated at least once a year, and it basically summarizes everything: the conclusions of your benefit risk analysis, the key findings from all your PMPF work, and even sales and usage data to give it all some context.
So, just to recap the whole feedback loop, think of your PMPF data as having a bunch of really important jobs. Job number one is to keep your performance evaluation report alive and kicking. It also helps you sharpen your benefit risk analysis. It gives you fresh info for risk management, and it might even tell you that you need to change the device itself or its instructions. And of course, for those high-risk devices, it's the backbone of evidence for your PSUR.
All right, now, just when you thought you had a handle on all this, let's talk about what happens when your IVD uses artificial intelligence or machine learning. Because let me tell you, that brings a whole new layer of challenges to the post-market world.
The first major hurdle is something called model bias. If you train an algorithm on data from just one group of people, it might not work so well for everybody else. If your training data isn't diverse enough, your device's performance could be seriously biased against certain ages, or ethnicities, or genders. Your PMPF plan has to be built to actively hunt for this kind of bias out in the real world.
Next up is this idea of model drift. An algorithm isn't a static thing. As it sees new and different data over time in different hospitals or labs, its performance can actually start to slip or drift. Maybe the patient population changes, or they're using different equipment. A good PMPF process is like an early warning system that can catch this drift before it causes a real problem.
And this last one, it sounds a little bit like science fiction, but it's a very real concern. Adversarial attacks. These are inputs that are specifically designed to trick an algorithm. There was a study where researchers showed they could add a little digital noise to an image of a totally harmless mole and make the algorithm think it was cancerous. It might seem a little out there now, but it's a new kind of risk that your PMPF process has to start thinking about.
Okay, let's bring this all home. We've talked about the what, the how, and the crazy new challenges. Now for the playbook. How do you avoid the most common mistakes and actually get PMF right?
Here are the top 5 things we see trip people up. Number 1, those vague plans we mentioned. They're non-starter. 2, PSURs that are either a giant data dump with no analysis or way too short with no real substance. 3, treating your initial performance evaluation like it's just a box you have to check. 4, and this is a huge one, not actually updating your plans based on what the data is telling you. And 5, creating a copy and paste nightmare where the same info is repeated over and over in different documents.
So what's the secret to getting it right? 1, be specific. Get all the details down in your plan. 2, integrate it. PMPF can't be off on its own island. It has to be connected to your quality and risk management systems. 3, be proactive. Go find the data, don't wait for it to find you. And 4, justify absolutely everything. If you decide you don't need to do a certain PMPF activity, the IVDR says that's okay, but you better have a really solid science-based justification written down.
So I guess the crucial takeaway is this. PMPF is way more than just a regulatory headache. It's a powerful tool. So as you look at your own process, you have to ask yourself, is my plan just generating paperwork to keep a file looking good, or is it a dynamic system that's actively making my device safer and perform better in the real world? Because the IVDR is pretty clear about which one it wants it to be. Thanks for tuning in.